Hi, I'm Emily from emilylearning.com. In this lesson, I'll be going through cube root and how to find the cube root of a perfect cube by prime factorization. So let's get started. So what is cube root? So a cube root of a number is a value that when 3 of itself is multiplied gives the original number. So let's look at cube root. So we represent cube root with this sign here with a 3 outside to represent cube root. So now when I write this, it is cube root of 125. So when I cube root 125, I'm finding a number which when multiplied by itself, okay, so I'm going to multiply itself 3 times, I get 125. Okay, and I know 5 times 5 times 5 is equals to 125. So therefore the cube root of 125 is 5 because 5 times 5 times 5 is 125. Okay, common cubes. 1, cube root of 1. So I know 1 times 1 times 1 is 1. So the cube root of 1 is 1. Cube root of 8 is 2 because 2 times 2 times 2 is equals to 8. So the cube root of 8 is 2. Okay, 27 is another nice number that you can cube root. So we know that 3 times 3 times 3 is equals to 27. So the cube root of 27 is 3, and so on. Okay, so a cube root of a number is not always a whole number. Okay, so just like you square root a number, you do not always get a whole number, right? So for example, if I were to cube root 18, I'll get this number when I type it into the calculator, 2.6207413839. Okay, so whenever you cube root a number and you don't get a whole number, it's going to be very difficult to evaluate it. So you always use a calculator to evaluate such cube roots. So when we cube root a number and we get a whole number, we call the number that we have cube rooted a perfect cube. So for example, 125 is a perfect cube. Okay, but when we cube root 18, we do not get a whole number, so 18 is not a perfect cube. All right. So finding cube root of perfect cubes by prime factorization. So the cube root of an index notation with powers that are multiples of 3 is a whole number. Okay, so think about it. If I want to find a cube root, I need to find a number that when multiplied by itself 3 times. Okay, the cube root of circle times circle times circle is equals to circle, right? So I need, in order to have a perfect cube, okay, I need the number, okay, to be able to be raised to the power of 3 or multiples of 3. All right. So for example, if I have this is circle to the power of 3, not 0. Okay, this is circle. Let me draw it this way. So if I cube root this number, circle to the power of 3, I'll get circle x. So now circle x is going to be multiplied 6 times. I'm going to cube root it. Do you agree I can split this into groups of 3? This power 6, right? Power 6 can be split into groups of 3. So when I cube root it, it will be equals to this. Okay, because cube root is basically finding a number which when multiplied by itself 3 times, okay, you get that number. So now I know that the cube root of this, when I multiply 6 of this cross I together, okay, and I cube root it, I'll get 2 of this cross I multiplied together. Okay, in other words, it's equals to cross I to the power of 2. So in other words, right, whenever you have index notation with powers that are multiples of 3, okay, when you cube root it, you'll get a whole number. Okay, and whenever you cube root something, you're going to divide the power or the index by 3. Okay, so cube root of 6, you're going to divide the power or the index, which is 6 here, by 3, which will give you 2. That's how you get 4. Okay, so now let's take a look at some examples. So In question 1, you're asked to express 64 as a product of its prime numbers in index notation and hence find the cube root of 64. So let's first express 64 as a prime numbers in index notation. So 64 is an even number, so I'll divide 64 by 2. I get 32. Divide 32 by 2, I get 16. Then I divide 16 by 2, I get 8. Divide 8 by 2, I get 4. Divide 4 by 2, I get 2, 2, 1. So in other words, 64 can be written as 2 to the power of 1, 2, 3, 4, 5, 6. So 2 to the power of 6. So now I'm going to cube root 64, and I know cube root 64 is the same as a cube root of 2 to the power of 6. And because this index here is a multiple of 3, okay, so to find the cube root of 2 to the power of 6, I'll simply divide this power or this index 6 here by 3. So 6 divided by 3 gives me 2. So in other words, cube root of 65 will give me 2 squared, which is equals to 2 times 2, which is 4. Moving on to example 2. So I am asked to express 216 as a product of its prime numbers in index notation and hence find the cube root of 216. So now let me express 260 as a product of its prime number. So this is an even number, so I'll divide by 2, so I get 108. Divide by 2 again, I get 54. Divide by 2, I get 27. Divide by 27, I get divide 27 by 3, I get 9. Divide 9 by 3, I get 3, 3, 1. So in other words, I can write 216 as 2 cubed times 3 cubed. So now I'm going to cube root 216. And 216 can be written as 2 cubed times 3 cubed. So when we cube root something, we are going to divide the index of each of these numbers of these index here, index notations here by 3. So 2 cubed, okay, I'm going to divide this power 3 by 3. So 3 divided by 3 is 1, so I'm left with 2. Next, I have 3 cubed. So to cube root 3 cubed, I will divide this power here by 3. So 3 divided by 3 is 1, so I'm left with 3. So the cube root of 216 is 2 times 3, which gives us 6.